Hey guys, Mike here from Ekim Knives, and I'm in the new shop, and I wanted to kind of discuss with you the importance of getting things flat. I know I've been talking about it a lot lately, and I've been kind of stressing the point. And there are a lot of reasons why. And today I'm going to give you a demonstration, not only to show you why you need to get things flat, but also some ways that you can do it, from the cheap methods to the more expensive methods. And which ones work the best. So first off, we're going to start off with our Makebelieve knife. So right here, pretend this is the handle, that's the other handle, and then we have a blade. I know it's, I did it on a chop saw. Close enough. But let's pretend that's centered. This was drilled and this was all flat. So now what we're going to do is we're going to take our piece that isn't flat and we're going to drill this. And I'll show you why not having it flat will mess you up and give you problems in the long run. So I'll take you over to the drill press now. Alright guys, we're over at the drill press and we have our piece that isn't flat. As you see, I just kind of chopped the taper on it. And then we're going to pretend this is our blade and we're going to drill it. We want our blade to center up nice. We want everything that we're looking for in a folding knife, in terms of quality. So we're just gonna, let's say we didn't flatten this somehow. It looked flat enough to us. Obviously, again, this is an extreme example, but just to illustrate the point. So you go to put it on your flat table and you're pushing down on it. You think it's flat. Look at this. You see that big gap under there? Now guess what happens when you go to drill it? So if I go to drill the hole right now while holding it like that, our hole is drilled, and to the naked eye it all looks good. But when it comes to knife making, a little mistake will translate into something big later on. So you want to get each step of the process perfect as you can. So now I'll grab my Makebelieve knife here and let's put our blade in our Makebelieve knife. So I'll take one of these handles off. Look at that. So now we tighten the pivot, let's say. You see that big gap right there? You see all that air through there? If I hold this loosely, now you can clearly see how off-centered the blade is. I mean, it's touching the other scale. So that's obviously an issue, and that's one of the important things of getting things, one of the important reasons for getting things flat. Now, some of you might be saying, well, it's really no big deal to me. I make fixed blades. That's all I'm interested in. I don't care about, let me tilt you up. There we go. I make fixed blades. I don't care about pivots and centering a blade. It's just one big piece of metal. So it's no big deal to me. But it is. And I'll take you over to my little surface plate behind me. Actually, it's actually kind of nice. I have to pick you up and transport you. Before, I just had to spin you around my tiny shop. Sorry, sidetracked. But even for you fixed blade guys, it is just as important to make sure you get everything flat. So I set up another example right behind me. And right here we have the granite surface plate, which is certified. That's how flat it is. So it's super flat. And here's our handle material that we just bought. We're going to attach it to our fixed blade. Let's pretend this is your fixed blade. And that's nice and flat. And it looks flat enough when you get it in the package, and then you bolt it up to your knife, you epoxy it in place. So now it's a permanent bond, and then you notice this. Do you see what I'm seeing? That big gap. Obviously, again, this is embellished, but these are the little things that can happen to you if you don't flatten your material, whether it be your blade or your handle material. So now, let's say you go to attach it to your knife, and you got that big old gap right there. And you could squeeze it all day long, there's nothing you can do. You're going to have a big ugly seam right there, and you don't want that. It would be different if the seam was even all the way around, but handle materials don't always come in perfectly. Some of the best stuff is G10. That comes in pretty flat most of the time. But I'll give you an example with some expensive carbon fiber that I bought that is all over the map. So stay put. Oh, all right. Here's the scraps that are left over from that expensive carbon fiber. If I put it down on our super duper flat surface, it looks flat. You see that? No matter where I hold it, I can find the spot where it'll click against the surface plate. And here's why. So we have our little dial caliper here. If I just take a random measurement, and it looks like I'm at right below the 80. Can you see that? Yeah, call it 79, so 279 thousandths, or I'm sorry, right after the 80, 281 thousandths. I'll just go to a couple inches back. Let's see. Whoa, what happened there? Now look where we are. Now we're at 306. Back here, 306 again. Let's go to another piece, and this is all the same sheet. Now we're at 276. You see what I mean? So this is actually, before we get moving on to the next subject, but this is a great way to check. Just take random measurements along with the grounded surface plate is a great way to check to see if everything that you have is in spec. Is you don't want that big old nasty gap. You don't want that crooked blade like this because you drilled it crooked. So those are some of the issues. Let me bring it back up here. So those are some of the issues that you can run into, and the end result is going to be nothing but headaches and maybe an ugly looking knife, something that you could have avoided. So now we're going to go over a few things you can do, even if you don't have a ton of machinery, you don't have the best of the best, even some hand methods of ways you can get it flat and what works the best, what's the cheapest, and then you have to decide for yourself on what's worth it to you. You know, if you're going for the fixed blade, you can cheat a little bit. It doesn't have to be perfect because some of the material will flex and bond together and you won't see the gaps. The more advanced you get when you're getting into frame locks and stuff like that, and I'm learning as I go that flat is paramount. It really, really is. So you want to make sure everything's perfect with those. So find out where you are in your knife making and your budget and see what fits you best. So alright, we'll go to our first method now. As you can see, I got 3 prototype folder blades. They're all the same blade, they're all heat treated, they're all the same steel. Right? These were all lapped on a surface plate like this beforehand. Before the video, before I sent them out for heat treat. But heat treat tends to warp them just a touch, so you're going to have to do this before and after heat treat if you want the best results. I dyed each one of them with red layout fluid, and I'll show you each one of the methods, and you guys can decide for yourself which one works the best, and like I said, which one's going to be affordable and doable for you. So we'll put 2 of these aside, and we'll start out with the cheapest. Yeah, it's definitely the cheapest method. It's the most labor intensive, and I'd give it an accuracy scale on 1 to 10 about an 8. And they're not perfect, just because if you're going to lap it on a plate, it's hard to control your hand pressure. So yes, the plate is perfectly flat, and if you rub it on here long enough, it'll get perfectly flat. But if you're doing this 2 hands or even 1 hand, the thinner areas are going to grind down faster than the thicker areas. It's just the way it is. And typically, like, I'm a right-handed guy, so my right hand is going to want to push harder than my left. Will it get it flat? Yes. Is it going to be perfect? No. That's why I gave it an 8. But the plate's like 30 bucks, and sandpaper is, you know, a couple bucks a sheet. So what you do is you take your sandpaper, and as you can see, it fits perfectly on there, and I dip it in water. So get it nice and soaking wet. You might have to wet it even more than that. And we'll give that a second just to sit. I'm going to grab some Windex. What you do is you spray some Windex on here. It'll give you some lubrication and help the blade slide around a little better. Now, why we dip the whole sheet in water is because it'll form a suction to this flat plate. So after some time, after it gets soaking wet enough, it'll naturally just stick to the plate. So, okay, the side we want to grind, that's our dyed side. We're going to put that face down, just like that. And you're just going to rub and rub and rub and sand away. The benefit of this is you could change grits, and of course this little fly is going to annoy me. You could change grits, so you could do your finish work on here. You could put an aggressive grit. This happens to be a 120 just for our purposes. Now, the proper way to do it, from what I understand, is figure eights, because it'll help even out that hand pressure issue that I was talking about by doing the figure eights. But eventually, you're going to end up wanting the lines to go long ways. And as you can see, our die is gone. So this one is pretty flat. I mean, that was very, very quick, but to get deep scratches out takes a while. And you're going to have to do it, to take 0.02 of an inch off, I had to do that once. It took me an hour. Literally an hour of doing this. Okay? So, cheapest method, works pretty good, but very, very time consuming. Alright, on to the next method. As you might have guessed, the next method is the grinder itself. Now, I'm going to put expense, I mean, a grinder is expensive. But if you're a knife maker, you don't really think about that. You're just going to end up getting one of these eventually anyway. Even if you're doing this on a 1x30 right now, obviously you can't do this on a 1x30, this method. You'd have to do the hand method. Excuse me. But if you do have a 2x42 or something big enough where you can lay the blade flat on the platen like that, it works out great. So cost is up to you, what you have available to you. As far as time, it's very quick. It's a few seconds and you're done. But accuracy is the problem. That's the trade-off with this one. Accuracy, I give it about a 4 out of 10. Because what belts like to do, and it doesn't matter how tight you make these, belts will want to flex out. So they'll go out and then go suck back in under the blade, and then they'll want to fan back out. It's just the way they are. So typically, you'll grind too much off the tip, too much off the back, and it won't be perfectly flat. But for a fixed blade, you might get away with it, and it might work good for you. Now, even if you think the platen isn't perfectly flat, mine is. I surface ground it on a surface grinding machine, which does get things perfectly flat. So even with a perfectly flat platen and a super tight belt, I wrestle mine on, you're still going to have issues. So I'll show you how this one works. Now here's our die blade. Get some tracking going here, and you're just going to push into the throat. A few seconds. As you can see, hand pressure is about an issue too. Hand pressure is an issue on this one as well, because even on this little blade, and even with a magnet backing it, I could easily put the force down here. I could put the force up top. It's very hard to get the force centered because you're relying on your human ability to do so, and we're just not that fine-tuned of a creature. So you can get it pretty close, and like I said, I'll finish this one up so you can see it. So I gotta take a little more off there. Okay, we'll call that good enough. So, as you can see, it looks pretty flat, but I can guarantee you it's not perfect. The more you do it with the belt, the worse they get. So you want to just get it flat and then stop, because you'll get more rollover. And actually, I have an example to show you. Okay, here's a blade from one of my very first batches that I did this method, right? And I was new, so I did it and I just let it run on a sloppy machine. It wasn't even this one. And to get the knife flat. Nowadays, this was just yesterday actually, I pulled it out just for giggles to see how far off it was, and I surface ground it. As you can see, the surface ground part is nice and flat, but look at that tail. You see that part? That's from the belt rolling up and grinding too much off the corners. So just be aware of that, that's what a belt will do to make your when you're trying to make your parts flat. So it works good in the middle and not so great on the edges, so just be aware. Okay, another method, as you can see, is the milling machine. Now what the milling machine will do is you get something called a fly cutter, and this one here is the Tormach Superfly. Probably one of the better cutters I've ever used for a milling machine. Downside to a milling machine is they are an expensive piece of equipment, so not every knife maker is going to have one of these. But if you do have one available, you owe it to yourself to get a fly cutter. They work very well for cutting steel and titanium and what have you. They can get it pretty close within about 1/1000th of an inch or so, depending on how rigid your machine is. Now that brings us to the next issue, is if you're using a mini mill, which this is considered a mini, they're not nearly as rigid as something a big monster Bridgeport or something like that. So you can only take off a little bit at a time, and with harder materials it's going to chatter and it's probably not going to work. Soft materials, aluminum, these are great. The other issue is it takes a little time to set up. You have to make sure everything's trimmed, everything's nice and even and level. So setup time, it's like any milling operation. And the reason I'm not showing you right now is because I spent quite a while setting up my rotary table here for another project. So I'm not going to take that down. I do have some footage though, I think. If I do, I'll pop it in right over here to show you a quick view of how it works. It leaves a kind of a circular surface finish, just like a disc grinder would, which is kind of a drawback because you're going to have to sand that out. But otherwise, accuracy, I give it a 9. It's pretty accurate. Cost is terrible because these machines are expensive. Even the cutter itself, this cutter was about $200 just for the cutter. So if you have a mill, you know how expensive it gets and how quickly it gets expensive. But it works great, and time, it goes by pretty quickly. So that's it for the milling machine. And as I alluded to, the disc grinder, I don't have one of those in my shop. I've been meaning to get one forever. Excuse me. I've been meaning to get one forever, but it's a flat disc that spins around, and you take the blade and you put it on the disc. Now you glue the sandpaper, the abrasive, directly to the disc, and they're usually direct drive. So there is no run out, there is no wobbles, the disc is perfectly flat, and they work great. You still have the hand pressure issue, and the fact that they're a terrifying machine, because anything with blades that spins has the ability to throw it at you, and these will throw it at you with some force. So just be aware of that. I don't want to comment too much more on them because my use with them is very limited. I have used one or two, and it's just, from what I understand, the way to go with those are the variable speed ones, but then your cost goes way up. Take you for a walk over here to the big behemoth, and we got this guy. So let me put you in an area where you can see this nice and clear. For this one, I'm going to give it a grade of horrible for cost because they're extremely expensive. It also gets a grade of horrible for space because they're huge and heavy. But I give it a 10 out of 10 for flat. And that's what this machine was built for, to make things flat. So, of course, when you use a purpose-built machine, it's going to be your best option. But, as I said, huge, expensive, So you have to figure, is it worth it to you? So I'll fire this one up and I'll show you how it works. So we have our blank, it's already on the magnet, and that holds it nice and stable. And this is ground in to 1/10 of an inch, a couple of tenths of a thousandths of an inch relative to the spindle. So it'll get perfectly flat. So within a half a thousandths usually. So we're all set up here and ready to go. Fire it up. And do a quick pass, quick pass. As far as time goes, it's fantastically efficient. They don't hog off a ton of material, but what took me an hour on a granite plate takes me a minute on this machine. And that's about it for this one. Shut that off. Disable our chuck. We can actually pull the part off. And as you can see, would that take all of a minute? And we're pretty flat. I mean, that's perfectly flat. And you can take it as far as you want. And surface finish isn't perfect, so you're still going to have to sand it and make it, you know, a knife finish. But it works great. So that about wraps this one up, guys, and I really hope that was helpful to some of you in explaining the importance of things, getting your blades and your handles and everything you use in knife making perfectly flat. Flat is the way to go. It'll save you so many headaches down the road. Don't learn the hard way like I did. Okay, so find out what you can afford, how important is it to you, and then take it from there. But this is Mike from Ekim Knives. Oh, before I do my little sign out, I saw all your comments. So every one of you, yeah, I'm watching, I read them. You know, sometimes I'm not the best at replying back, but I try. I really do try, guys. And I do have an excuse, a valid one at that. Excuse me. YouTube was screwy a couple of weeks ago, where I would get an email that I got a comment. Oh no, I wouldn't get the email. Or the little red notification that I got a comment or a reply or something like that. And it would just show up on my phone for a second, and as soon as I unlocked it, it'd be gone. So I did miss a few comments. I have no idea where they went. But it wasn't me, guys. I'm not ignoring you. It was a YouTube thing. You know. And if I do miss it, I apologize. I try to get to everybody. What I'm getting at is I saw a lot of you requesting tutorials for removable handle scales. I know that one's been requested a lot. I just need to have some fixed blades in-house so I can show you the tutorial. Right now I don't have any fixed blades. I plan on getting some. I have some more steel coming in, and I'll show you a tutorial then. Mirror polishing is another one. Hollow grinding. To name a few, how to mill a fuller on a blade. If you have any others, you know, put them down below. I can't promise you I'll get to them soon. I have a laundry list of videos to get to. But I'm just going to keep pumping them out as fast as I can, guys, and take you along for this whole knife making journey. This is Mike from Ekim Knives, and I'll catch you on the next video.